Here we have the function f of x equal to x to the fourth plus x to the third minus 3. And so the derivative will be 4x to the third plus 3x squared. And we want to use Newton's method to find the x-intercept of this function right here. This is what the graph looks like. And here we have two x-intercept, two real number x-intercepts. And because this function is x to the fourth, and so some of the zeros might be imaginary numbers, but the real zeros are these right here. And so it look like this is about 1.05, and this look like about negative 1.8. And so let's use Newton's method to find these two zeros right here. And so on the first one, we want remember that in Newton's method, what we do is pick an initial guess, meaning pick the number that's close to this zero or this x-intercept right here. So we could pick 0, or we could pick like 0.5. And so remember that Newton's method involves dividing by the derivative. And so we don't want to pick an initial guess where the corresponding point would have a horizontal tangent line, because horizontal tangent line has slope of 0, and so that's where the derivative is 0, and we will be dividing by 0, and that's going to lead to a problem. And so for this one, pick something like 0.5 for an initial guess. And so we pick 0.5 for the initial guess right here. Then the corresponding point would be right here. So this is the point with an x of 1.5, with an x of 0.5, and then draw the tangent line through this point. And this is what it looks like. And then the tangent line has an x-intercept. It looks like it's about 2.7. And so let's calculate it. Calculate the x-intercept of the tangent line. And so our guess value, initial guess, is 0.5. And then we need to calculate f of x of y. So go to this function right here. In the place of x, put 0.5. And if simplify, it will give us negative 2.8125. And then we need the derivative of f of x of y. And so go to the derivative in the place of x, put 0.5. And then that will give us 1.25. And then next, calculate this quantity right here, which is the x-intercept of the tangent line. So it would be 0.5 minus negative 2.8125 dividing by 1.25, and that will be 2.75. And now we go back and look at the graph, we will see that the x-intercept of the first tangent line will be 2.75. The x-intercept of the first tangent line is right here, which is 2.75. And then we calculate the difference between the guess value and the x-intercept. And so 0.5 minus 2.75, absolute value is 2.25. And so the difference is too large, so we go to the second iteration. And remember that in the second iteration, the guess value will be the x-intercept of the previous iteration. In this case, it's 2.75. And then we start the process all over again. So we need f of x of y. This time x of y is 2.75. So go back, go to the function here. In the place of x, put 2.75, 2.75. And that will give us 74.98. And then go to the derivative and plug in 2.75, and it will give us 105.87. And then calculate the x-intercept of the second tangent line. And so it would be 2.75 minus 74.98 dividing by 105.8, and that would be 2.04. And now we go back to the and look at the graph. We will see that the second tangent line has an x-intercept of about 2.04. And so there's the second tangent line right here, and the x-intercept is about 2.04. And then the last column, we calculate the difference between x sub I and the x-intercept, and the difference is 0.70, which is too large. And so next, we go to the next iteration. And now we will go to Google Spreadsheet to do all these calculations. And this is Google Spreadsheet. And so first, label the columns. So we have the iteration, we have the x sub I, which is the guess value, guess of the zero of the function. And then next we have f of x sub I, and then the derivative at x sub I, and then x sub I minus f of x sub I dividing by the derivative f of x sub I. And again, this is the x-intercept of the tangent lines. And in the last column, we want the difference between x sub I and the x-intercept. And recall that with the example we on, the guess value was, the initial guess value was 0.5. And then next, we want the function at 0.5. And so our function is x to the fourth plus x to the third minus 3. And so in the place of x right here, we would put 0.5 and 0.5. And so this is how we would input the function into the spreadsheet. So the equal, and then this is x right here. And so is in cell B2. And so we would do B2 and then hat 4. So that's how we do to the fourth. And then plus B2 to the third. And then minus 3. And it will give us negative 2.125. The derivative is 4x to the third plus 3x squared. And so in the Excel, we would type it in like this. It'd be equal 4 times, and then B2, because that's where our X is, and then hat 3, and then plus 3 times, and then B2, and then hat 2. So that's how we would type it into the Google Spreadsheet. So 4 B2 to the third plus 3 B2 to the second equal 4 times B2 to the third, and then plus 3 times B2 to the second, and then enter. And we will get the 1.25. 1.25. And then this column right here, we will do equal x sub I is then cell B2, so we can click on it, and then minus f of x sub I is in C2, so clicked on it, and then divide f, the derivative of x sub I is in D2, so clicked on it, and then enter. And there's the x-intercept of the first tangent line. And then right here, we want the absolute value of B2 and E2. So we do equal ABS, parentheses, and then B2 minus E2. And again, we're not happy with this difference, so we want to go to the second iteration. And in the second iteration, the guess value will be the x-intercept of the previous iteration. And the previous iteration is E2, so we would type equal E2. And then we want the process to start all over again. And so highlight, and then Control C on C for copy on the keyboard. And then click on this cell and then Control V. V's in Victor for pasting. And so for iteration 2, the x-intercept of the second tangent line is 2.04, and then the difference is 0.7, so it's too large, so we go to iteration 3. And this time we wanted the guess value to be the x-intercept of the previous iteration. So it's in E3, so equal E3. And then highlight, and then Control C on the keyboard, and then click on this cell and Control V for pasting. So at the end of the third iteration, we have a tangent line with the x-intercept of 1.55, but the difference between x sub I and the new x-intercept is still too large, so we go to iteration 4. And so this time, the guess would be the x-intercept of the previous iteration, so equal to, this one would be E4, so it would be E4. And then copy this row, highlight, and Control C, and then click on this cell and Control V for pasting. So at the end of the fourth iteration, the x-intercept of the fourth tangent line is 1.25. The difference between x sub I and the x-intercept is still too large, so we go to iteration 5. And the guess will be this value right here. And then copy, Control C, and then Control V. At the end of the fifth iteration, the x-intercept of the fifth tangent line is 1.13. The difference between x sub I and the x-intercept is still too large, and so we go to iteration number 6. And this time it will be equal. We start the guess value of the previous x-intercept, which is in E6. And then copy, and then paste. The difference is still too large, so we go to iteration 7. And again, this is the previous iterations x-intercept, and is in E7, so equal E7, and then copy. The formula is here, and then click on this cell and then Control V for paste. The difference is getting better, but it's still too large, so we'll go to iteration 8. And then the guess value will be the last iteration's x-intercept, which is E7, which is E8. And so we clicked on that, and then copy. And the difference here is small enough, and so the x-intercept of the function is 1.122909113. And so this x-intercept right here is 1.12. So that's what this one is. And now let's say we want this x-intercept. And so let's be the initial guess be -3 right here. So this looks like it's about -1.8. So go back to the spreadsheet, and in the place of the initial guess, put -3. And everything will get updated automatically. And so that x-intercept is about -1.658. Right here is -1.658. And so that's how we use Google Spreadsheet to help us do the calculations when we use Newton's method to find the zero of the function right here. Function